In this video series, I work through a math problem or problems each video. When we add rational expressions together, we first need to make sure that all the fractions have the same denominator. If they don't share the same denominator, we'll use the methods we learned in the previous video to find the least common denominator first, then rewrite all the fractions so that the denominators are equal to that least common denominator. Then we can rewrite the sum or difference as a single fraction and simplify the numerator. Let's take a look at the example. We need to add or subtract as indicated and simplify the resulting expression. The three fractions that we're adding together here are x plus 2 divided by x plus 5, 2 divided by x minus 5, and 4x minus 10 divided by x squared minus 25. Let's go ahead and factor the expression x squared minus 25, so we'll see if this x squared minus 25 already contains either or both of the linear factors. X squared and 25 are perfect squares, so we have a difference of perfect squares here. So we can rewrite x squared minus 25 as x plus 5 multiplied by x minus 5. And if we compare what we have here to the denominators in the first two fractions, we see that this multiple here is actually the first two denominators multiplied together. So in order to match these three denominators, we just need to multiply the first two denominators together. So to the first fraction, we're going to multiply the second denominator, and to the second fraction, we're going to multiply the first denominator. So we're saying that the least common denominator for these three fractions is x plus 5 multiplied by x minus 5. So let me write that out. We're going to multiply the denominator by x minus 5, then do the same thing to the numerator of the first fraction. Then we're going to start with the denominator we originally had, x minus 5, then multiply that by x plus 5. Then we're going to multiply the numerator by that same fraction, or same expression, x plus 5. And for now, we're going to leave the third fraction alone. If we take a look at the second fraction, the order in which we wrote x plus 5 and x minus 5 is different, but since multiplication is commutative, we can go ahead and switch x minus 5 and x plus 5 to get x plus 5 multiplied by x minus 5. And when we do, all three fractions will end up with the same least common denominator. So once we do that, we can combine these three fractions and write this as a single fraction. Next, let's multiply out the expressions we have in the numerator. We're going to be using FOIL to multiply this out. So we get x squared, and for the linear terms, we get 2x and minus 5x, and 2 minus 5 is minus 3, so we get minus 3x. 2 times minus 5 is minus 10, and we get 2x plus 10. we can copy the plus 4x minus 10. And we'll copy the numerator, the denominator. Now we can combine the like terms in the numerator. X squared, or the quadratic terms, appears only once, so we'll go ahead and copy x squared. Next, we look for the linear terms, and we get minus 3x plus 2x and plus 4x. So minus 3 plus 2 plus 4, 2 plus 4 is 6, and 6 minus 3 is 3. So we get 3x. And finally, for the constant terms, we have minus 10 plus 10 and minus 10. So minus 10 plus 10 will cancel out, and we'll be left with minus 10. Then once again, we copy the denominator. Next, let's factor the expression we have in the numerator. Since the coefficient or the quadratic term is 1, we start out by writing x and x. 10 is equal to 1 times 10 and 2 times 5. The minus sign in front of 10 tells me that we're going to be subtracting the numbers. 10 minus 1 is 9, which doesn't match 3, but 5 minus 2 is equal to 3, so we write 5 and 2. Since 3 is a positive number, we make the bigger number positive, so we get x plus 2 and x minus 2. So we have x plus 5 and x plus 5. They both appear in the numerator and denominator once each, so we can cancel them out. And we'll be left with x minus 2 divided by x minus 5.